Alright, this is a quick little lesson on the circle and ellipse, which hopefully will help you do those worksheets that I sent home. Alright, this should be really quick and simple, but the first thing I want you to know is the standard equation for a circle looks like this. Both the x and the y are squared, and you're adding, and it always equals the radius squared. So look right here. This first one, this is not a 1 on your worksheet. At least I don't think so. I just made it up real quick. But I can see real quick, just by looking at this, that my radius is going to have to equal 8. Because, remember, this equals radius squared. So in order to solve for radius, you're going to take the square root of both sides. And the square root of 64 is 8. So my radius is 8. Now, this is a standard equation for a circle where the center is 0, 0. So I know this center is 0, 0. And I'll show you one here in a minute that it's not. So to graph it, you don't have to really plot points or anything. Go up here and plot your center. And there it is right there. And because my radius is 8, I'm going to go up and down 8 and back and forth 8 from the center. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to have to kind of approximate. I'm going to do the same thing this way. Go 8 this way, 8 down, and 8 up. And then I have a huge circle. You can just kind of sketch this out. Okay, or you can get a compass if you're real, picky about it. But that's good enough. And I just tell students, just label a radius, any radius. All of these radiuses right here, doesn't matter. As we know, they're all 8. Okay, because that's how it's defined. Now, here is another circle. Okay, and I tried to keep it very similar to the first one, except for now my center is not 0, 0. I got some stuff being messed around, okay, with my x and my y. What you can do to find your center is it's what makes this 0. So this value would be 1, okay, because 1 minus 1 is 0. And this value would be negative 3. So that right there is my center. And I'm just going to be real lazy and call it C for center. Again, this always equals my radius squared. So my radius here would be 8. So again, it's too bad I made this so big because it's going to go off my graph, but start with your center at 1, negative 3. So there's 1, 1, 2, 3. That right there is my center. And then I'm going to go up and down 8, back and forth 8, just sketching a little circle. Those would actually be points on my circle. 1, 2, 3, 4, 5, 6, 7, 8. Okay? And then go back, do it all the same way. Mine's so big, I don't really want to put this on my graph. 1, 2, 3, 4, 5, 6, 7, 8. So about here, 1, 2, 3, 4, 5, 6, 7, 8, and vice versa. And then you're just going to sketch in this circle again. Make sure, I'm trying to do this and hold an iPhone, so it's not real good. Okay, but we're sketching in a circle and go all the way around. And then we're going to label some radius. It doesn't matter. Pick a radius, and we know that it's 8. All right. So that's the circle. Now, this is an ellipse. The standard equation for an ellipse, where the center is 0, 0, let me come back up here and I'll write it down for you. It looks like this. We are just doing the basics. Notice both the x and the y are squared. We got some values under here that are also squared, and it has to equal 1 for it to be in standard form. Okay, first of all, that wasn't true with the circle. Both my x and the y were squared, we were adding, but it didn't have to equal 1. Okay, this one did. Okay, and I'll show you some little tricks here. Okay, so, I don't know if I said this, but my center is still 0, 0. Nothing's changed. So we're going to do this the same. My center is 0, 0. Just look at the numbers at the top. It's what makes these values 0. So my center is 0, 0. So we're going to come up here and label 0, 0. Now, this is the easiest thing to do. Under the x, we have a 4. Now, we all know the x-axis runs this direction. So this is going to tell me how far to move back and forth. And how you find it is whatever this number is, you take the square root of it. And the square root of 4 is 2. So I'm going to go back and forth 2. Okay? So from my center. So my center was 0. So I'm going to go back and forth 2. So I'm going to go from the center, 1, 2, make a point, go left, 1, 2, make a point. Now, under the y, and we all know that the y-axis goes up and down, you can figure out how far to go up and down by whatever this value is. Just take the square root of it. And the square root of 16 is 4. So I'm going to go up and down 4 from the center. So put your pencil point on the center and go up 4. 1, 2, 3, 4. and go down 4. 1, 2, 3, 4. Now you can tell that's not a circle, okay, because it's not the same distance from the center, but it is a nice ellipse. So just draw this through like that, okay? So there's your ellipse. Now, what are your vertices? Your vertices are the longer part, the endpoints of the longer part. And you can see that this is longer than this is, okay? You can also tell that because the bigger number is under the y. So that means my vertices are going to be the points on the up and down. So just see, what is this point? Well, it looks like it's 0, 1, 2, 3, 4. So one of my vertices are 0, 4, and the other one is this point, which is 0, negative 4. And that's it. Okay. So look at this one. This is also an ellipse. I'm adding both my x's squared and my y's squared, and I've got it set equal to 1. So your center, let's talk about that, are what make these values 0. Here it would be a negative 2, because negative 2 plus 2 is 0. So it's going to be negative 2, and this one would have to be a positive 4, because 4 minus 4 is 0. So go ahead and plot that point, negative 2, 4. So you're going to go over 2, down 4, and there you go. It's right there. All right, so look under your x and you got a 25. Remember the x-axis runs this direction, so this is going to tell me how far to go left and right from that center point. And I'm going to go left or right 5, because the square root of 25 is 5. Okay, so we're going to go 1, 2, 3, 4, 5 to the left, 1, 2, 3, 4, 5 to the right. I'm just going to have to estimate because I'm running off my graph. Now this is a 10. And so how far are we going to go up or down? Because this is under the y, so it's going to tell me how far to go up or down. And I'm going to do something totally unprofessional here, because everybody knows I'm not professional. I'm getting in my junk drawer, getting a little calculator out, because I forgot to get it before I started. Why? I'll tell you why. Because 10 is a wonderful number, but it's not a perfect square. So in my calculator, I'm going to have to approximate the square root of 10. Remember over here, we took the square root of 25. Just so happened it was a pretty number. Okay, so I'm going to do the same thing, and I did this on purpose. Okay, we're going to find the square root of 10. Still a number. So in this particular calculator, I'm going to have to hit a 10 in, and I guess I'm going to have to turn it on. I'm going to have to hit a 10 in, and then hit my square root button. And it looks like, okay, we're approximating, so it's about 3.2. So what I'm going to do is I'm going to go up and down about 3.2. It's just from the center. So put your little pencil point on the center, and we're going to go up 3. 1, 2, 3, and just a little bit more. Okay, you're going to have to approximate. We're going to go down 3. 1, 2, 3, and just a little bit more. So about right there. This is an ellipse. So draw it in there real quick. Sorry. That's sick. That's what I get for trying to look through a phone and do it. Okay, if I had a little eraser on this, I could fix that up a little bit, but there's my ellipse. These will be my vertices because it's longer this way than it is this way. So this would be a vertice, and this would be your vertice. Those endpoints right there. You can also tell it would be going this way because my bigger number, 25, is bigger than 10. So this is going to be the longer length. Okay, so what is that point right there? Well, it is 1, 2, 3, 4, negative 4, 1, 2, 3. So negative 4, 3 is a vertice. And this one is 1, 2, 3, 4, 5, 6, 7. Negative 7. And I think I just wrote that down wrong, didn't I? We'll have to fix that. What did I do here? Am I freaking out? 1, 2, 3, 4. 1, 2, I counted. Gosh, that's what I get for looking through my phone. Okay, just a minute. 1, 2, 3. 1, 2, 3. Okay, yeah. I'm freaking out. That's 3, negative 4. Sorry, haven't had my coffee yet this morning. This one is 1, 2, 3, 4, 5, 6, 7, negative 7, negative 4. And that should be it right there. Okay, sorry. One thing I could have done as well is on my, here is my center. I added or subtracted 5, and usually I do this. One time I add 5 to this. Notice if you add 5 to this, you get a 3. One time if you subtract 5 to this, you get a negative 7. So that's usually the way I prefer. Okay. So let's look at these two. I wrote out two right here that are a little different, and they look so similar. And I'm telling you, one of these is a circle and one's an ellipse. Okay, how can you tell? Because they look so similar. This one is a circle, and I'll tell you how you know. First of all, both of them are squared and you're adding. Same thing here. Both the x and the y are squared and you're adding. So you're like, do you see how these numbers are the same? They're both equal to 4, but yet these numbers are different. Okay, so this one's an ellipse because my numbers are different. This one would be a circle because my numbers are the same. So when you get a tricky one, that's what you go. Now I like these values in here to be a 1. And since they're always the same, I can fix that because I can divide everything by 4. If you divide everything by 4, notice you're going to end up with x squared plus y squared equals 9. Definitely now looks like a circle. This is a circle with a center at 0, 0, and a radius of 3 because the square root of 9 is 3. Now just for a minute, pretend this would have been a 12, okay? If you get something like this where it's a 12, then you would write your radius, you know, you can be lazy, as the square root of 12, which technically is 2 square roots of 3. But anyway, you're just not going to get a nice pretty number. Don't worry about that if you don't get a perfect square. Sometimes they are, sometimes they aren't. Okay, so how do we graph this? Go to your center, which is 0, 0. And my radius was 3, so I'm going to go up and down 3. 1, 2, 3, 1, 2, 3. Okay, 1, 2, 3. I'm going from the center, 1, 2, 3. Notice they're all the same distance around, which is how you define a circle. And again, find some radius, I don't care what, but label it 3. Okay, all right. So we talked about this. We now know it's an ellipse because these numbers are dirty. They're different. Gosh, I am tired. But we know on an ellipse it's supposed to equal 1. Okay, so we're going to divide everything by 36. So that's what we're going to do different here. Notice the reason we do that is because this now equals 1. So my new equation is, I'm trying to think, where should I squish this in? You're going to get what? X squared over 9. So I'm going to write that right here. This one, you're going to get y squared over 4 because 9 goes into 36 4 times. So I'm going to get y squared over 4 equals 1. Okay, so what's my center? My center is 0, 0, okay, because nothing's being added or subtracted to either one of these values. So I'm going to go over here, plot my center. Under the x is a 9. Love that. Because it's the x value, it tells me how far to go this way. And I'm going to, what is the square root of 9? Oh, 3. So from the center, I'm going to go back and forth 3. 1, 2, 3, 1, 2, 3. Okay? Under the y always runs up and down. Under the y is a 4. Well, the square root of 4 is 2. So I'm going to go up or down 2. So go to the center, go up 2, go down 2, and there's your points. So through that, draw a nice smooth curve. There should be no sharp points at all. Okay? I don't want it to look like a diamond. Don't connect these and make a sharp diamond. Now, what are your vertices? Your vertices are going to be these endpoints right here because that's the longer. That is longer distance than here. Okay? So here's a vertice, which is 1, 2, 3, 0, and the other vertice is negative 3, 0. Okay? So that would be your vertices. I think I may have done one more real quick. Here it is.